Hello, I would want to thank you for watching my videos. So this is my lecture video for exam P1. Uh, so I'm Dr. Wang. So this is from for problems from 111 to 120. Okay. So this problem says, as I say, this is two variable continuous distribution. So what we wanted to do is giving that. So giving that means conditional probability. Giving that uh, this this is to determine the probability that these things between A1 and 3. So let's say what is initial claim for by the company, and what is the set amount. So let's say so initial let's say okay, what is x? So let's say x is amount it will pay, right? So the y is, what is y? The company pays an amount of y. Y is the final payment. Okay, so here this means that this final set, this is y, and this is x. So this problem just become like this. We want to find so that y is between 1 and 3, giving that this x equal 2, right? Okay. So when x equal 2, what is density function? So we just find the density function for when x equal 2. So this density function is just we plug in x as 2 to y. So this equal when x equal 2. This is a constant, right? So here we just say this is just a constant, like 2 square 1. Okay, so here the so x equal 2. So oh, I'm sorry, not y is negative 2x minus 1. So x equal 2. Just y3, right? So this marginal function, just there's some coefficient k at y negative 3, and this y is larger than 1. So what is the k? K, we just make this good. This is density function, right? So in all integration is 1. So we say like all integration is 1, like k y negative 3 dy from 1 to infinity. So this equal 1. So from here we can find k, right? So k equal, so from here we can find k. So y negative 3 integrations negative 3 negative 2, 1 over 2, right? So 1 over 2. So this k should equal 2. Okay, so by now this problem become very easy, right? So the density function is thus. So the density function for y is thus 2y negative 3 and y is then 1. Then we want to find this probability y between 1 and 3. So this is just equal from 1 to 3, like 2y negative 3 dy. Right? So this equal just y negative 2. Y negative 2 integrate out 1 3. So this equal 1 minus 3 square. Yeah, 3 square. So, okay. So this problem is giving that there's 10% by 10% of this thing. What is the probability that this is like this fusing 5%? Okay. So this is conditional probability. Okay. So what is, let's say, so here we have x and y. So x and y. What is x? So x is a proportion who will purchase the basic policy. Okay, so this means that when basic policy, so we want to find the probability, right? Giving basic policy is 10%. Then this y is the proportion for purchase supplemental policy. So we say this is what the probability that this y will less than 5%. Okay, so this is such a conditional probability, right? Okay, so we know, so when x equals 0.10, we just defined the density function for y. So here, so when x is fixed 0.1, y so equals us, right? Equal 2 times 0.1 plus y. But in order to make this as the density function, so total all integration should be 1. So actually, maybe we need to adjust this. So maybe let's say this is equal to k times 0.1 plus y. So what is the range for y? Y is between 0 to 1. Right? Okay. So what is k? So we can find that there's a k, right? So there's a k. So there's a k is when 1 equal when y equal all those integration, yeah. So k 0.1 plus ky. So dy. So this equal 1. So this integrate out. So first one is just the 0k times 0.1. Second one is k y integrated half, right? 0.5. So this equal k times 0.6. So this k. So we can find this k is 1 over 0.6, right? Okay. So now the problem becomes just to find this probability. Okay, so there's a probability y is from 0 to 0.005, and the density function is 1 over 0.6. So here 0.1 plus y. So dy. Okay. So this probability is equal 1 over 6. Okay. So then 0.1 integrate out 0.1 times 0.005. So plus, so y integrate out is half 0.005 square. Okay. Okay. So this problem we want to find what is expected value, expected excess of payment over claim. So we want to find this. We want to find this expected value for premium over claim, like P premium minus claim, right? But here we have a giving that, so this is conditional expectation. So giving that the husband survive, okay? So we need to check those conditions, okay? Okay, so now let's say the story is we have 2 life insurance policy, each with death benefit thus, and the one-time premium is 500. So this premium is fixed. This premium is 500. Okay. So this policy are sold to a couple, the husband or wife. Okay. So the probability that only the wife will survive is thus. So for wife or husband, so for wife we have 2 cases. The wife can survive and wife will die. So we just use this notation, right? And for husband will survive, husband will die. Okay. So this probability, so we can use the table. Let's see. Okay. So this is the probability only the wife will survive. Wife will survive and husband will die. So this probability here is 0.025. Okay. Oh, and only husband will survive. So wife will die. So this is 0.001. Okay. And the probability that both will survive. So both will survive is thus. Okay. Saying both will die, let's see. So we can find the probability that both will die is so 0.005. Okay. Okay. So the condition is we condition the husband will survive. So we just check this. Okay. Alright. Okay. So so we just have this probability. So why this wife? So we just focus on this wife. Wife will survive or will die. Okay. So there's a probability. Probability is 0.96 or 0.001. But this is not a distribution. Total probability not 1. So we just make the total probability is 1. So here add them up is not disturbing, right? So just like that. So this is we know this condition. So conditional distribution for wife, right? Okay. So there's expectation claim is here. If not so here if there's W wife survive, no payment, pay 0. Here pay let's say pay 10,000, right? Okay. So we can find this. So premium is 500. So just equal 500 minus expectation for payment of for claim. Okay, so this equal 500. So minus, so payment, so here pay 0 and here pay so much, right? And the probability is 1 over 97. Okay. So for this problem, is two variable discontinuous. This is easy. Like, so we just check. We want to find the variance for y under this condition. So when x equal 1, this y, the distribution for y is y, x equal 1 only here or here, right? So y can be 0, y can be 1, and the probability that y equals 0 is 0.005, and y equal 1 is thus. Okay, so this is not distribution, so we wanted to say this is y is 0.1, and the probability should equal so totally is 1.005, 175, right? So here we can say this is the 5 over 175, and here 125. Oh, I'm sorry, here 50. Yeah, it's 175, right? 0.053. Yeah, we so don't make it mistake. So here we use 3 decimal digit. Yeah, so 50. Okay, so this is 0.1 distribution. So for this 0.1 distribution variance, we know. So let's check this. Like remember, like 0.1 and PQ. So this binomial distribution or Bernoulli distribution's variance is PQ. So here, this variance for this y, so just equal this PQ, like 50, 175 times 125, 175. Okay. Okay, so for this problem is conditional variance of y giving this. Oh, this is just like a v conditional y when x equal x. Okay. So again, so when we want to find this variance, we didn't know the distribution for y when x equal x. Right? So when x equal x, so let's say this is so here the range for x and y x is from 0 to 1. Suppose here 0 to 1. So y from x to here x plus 1. So here the y equal x, y equal x plus 1. Okay, so say this range is this part. Okay, so okay, 0. Okay, so when x equal x, so when x equal x, like x equal x, well, fix this x. So what is the distribution for y? So y is from here to here, and so that's the function we just plug in. We just fix x. So we find when x fixed, so 2x is fixed. So this we can say this density function is constant. So we know this the distribution for y is uniform distribution from this point to this point, right? So we say y actually for uniform distribution from x to x plus 1. Okay, so once we know this, so for uniform distribution, so we have the formula, right? For uniform distribution from A to B, the mean is midpoint, but the variance is, we have this formula, right? Vy variance is 12, so here's B minus A squared. Okay, so here plugging here is just the 12, so x plus 1 minus x is 1, so 1 squared. So this is 1 over 12. Okay, so this is discrete distribution, so very easy one, right? So here we say, so given that the conditional probability, given that there no tornado in county P, so when P equals 0, so Q, so the distribution Q is just like that, right? Q can be 0, 1, 2, 3, and the probability for them is 0.12, 0.006, 0.005, and 0.002. But this is not a distribution because all probability add them up is not equal 1. So we just make this equal 1. So we just divide by total here. Total here is 0.12, 6, 5, and 2. So we find this equal 25, right? Okay, so we just check 25, 0.25, 0.25, 25, and 25. Or we don't like this decimal, so like distribution like this. Here's 12, 25. So we just use 25. So here's 6, here's 5, and here's 2. Okay, so for this distribution, we want to find variance. So by now it's easy, right? So just equal just some calculation, q square minus eq square. Okay, so this is just a simple calculation, so we can easily find this. So for this problem, let's say we need to determine the probability that the proportion with this to this is less than 0.2. That is the proportion of a claim represented to damage to the house. This is less than 0.2. So let's say, so this is x and y. Let's check. Okay, the claim representative damage to the house is x is the claim damage to the house, right? So we need to find this. So there's x less than 0.2. We need to find this probability. So this is not a conditional probability, just a regular probability, right? Okay, so for finding the probability, so this is, let's say, 2 dimension. two variables. So here x and y. Okay, and so the range is x larger than 0, y larger than 0, x plus y less than 1. So let's say that this is x plus y equal 1. Okay, so we know the range is this triangle, right? This triangle. Okay, okay. So we want to find x less than 0.2. So from 0 to 0.2. So we just need to find the probability this part. Okay, so this part is we just check x. So x from 0 to 0.2 dx. Okay. Then for this x, y is from 0 to 1 minus x, right? So dy. So y, the range for y is from 0 to 1 minus x. Then plugging this density function. Density function is 6. We put 6 here. 6, 1 minus x plus y, or 1 minus x minus y dy. So this problem is just a simple double integration, right? So let's do this double integration. So we see such a problem is quite regular or simple. Okay, so this 1 minus x, really this is constant, right? So this integrated out is 1 minus x times the distance for this upper bound, lower bound is 1 minus x. This is 1 minus x squared. Okay, so minus, so y integrated out is half y squared. So this is square. Okay, so we know this integration is just like this. So this equal half, right? Half of this 1 minus x squared. So this equal, we say 3, 0.2, 1 minus x squared dx. So for this integration, we can expand, or we can use substitution. We just let 1 minus x equal t, so we just say equal t squared, right? So equals this. So here t squared dt, but there's a negative dt, right? So when x equals 0, 1 minus x equal 1. So when x equal 0.2, this is 0.8. So this integration just like that. So we know this equal t3, right? Integrate out this t3, 3 over 3, so cancel. So this is just 1.8. So this equal 1 minus 0.83. So for this problem, we say we want to find the density function or marginal density function of y. So from this join the density function. So just remember, how can we get the join the join the density function to marginal density function? Just let's check the discrete situation. Okay. Like here, the x can be this number, y can be this number, then here those are probabilities. Okay, so how can we find the marginal distribution for x? For x, so x can be this number, then probability is just for each fixed x, we just added those y probability, right? This y add this. So if we wanted to find marginal distribution for y, so we just added for this, like in this direction, right? Added those x for fixed y, like y fixed, y equal fixed. So just added those x. Okay, So here, same story, right? Okay. So let's say the density joint density function is the range is y between x and x squared. So this is y equal x and y equal x squared. Okay. So here y equal x squared. Here's y equal x. So the range is like this. So here's 0 and this is 1. Yeah. So this is x, this is y. Okay. So find marginal density function for y is we for fixed y, let's say for this y, we need to add those x, added all those x. So this means like we for fixed y, we need to add this. Okay, so we need to add x dx. So x from this point to this point. So for this line y equal y. So this x, small x, for fixed y, so this x is y, right? And from this x to this x, so this x is radical y, right? So from y to radical y. Saying this fxy, so that's the function 15y, so there's a 15y. So dx. Okay. Yeah. So here additions, integrations about x for y fixed. So this equal so 15. So y constant, right? So radical y minus y. Okay. 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 So we can find the answer is D, right? Okay. So for this problem 119, what we want to find is what is the probability the payment to the other driver's car will be greater than this. Okay. So for the payment to other car, so here we denote this as y, right? Let's say this is the size of payment to policyholder's car X, and the other car is Y. Okay, damage to the other car is Y. So here, what we want to find? We want to find this. Y is greater than we want to find this, right? This is y. Okay, so here's the find probability for two variable, two dimension. So we need to check the density function or join the density function for that. So here, let's see. So the x is between 0 to 1. Between 0 to 1. Okay, so we know marginal density function is 1. So here we know marginal density function. We want to find joint density function. So for this is this is just like well, for probability. Let's say joint density function is a probability for both of them, right? So we have this. This equal PA. So this is we forget it as B. So this is like a marginal density function, right? Net marginal probability. Okay, so then here is conditional probability, right? So here we have this the marginal the joint density function equal marginal density function x, then multiply this like x for x fixed, x for x, then this is the conditional density function for y. Yeah. Okay. So let's say so here for giving x equal x. Suppose here's 0, here's 1, so here x equal x. So y giving x equal x, the y the size this y has a conditional density function for 1 constant for y between x and x plus 1. So here's between x and here x plus 1. Okay. Y equal x, y equal x plus 1. Okay. So this condition, and then here is from here to here is constant 1. Okay. Okay. So we know this joint density function is just 1, right? Constant. And integration, the range is just the third part, right? Okay. Okay, so now we can easily find do this calculation. Okay, so let's say y equal y larger than 0.5. So maybe my graph is not so good. So we had better to have good bad graph. So here suppose this is 1, then y equal x, and here y equal x plus 1. So and y equal half. Okay, so y equal half. So y we want to find y larger than 0.5, right? Y larger than 0.5 is this part. So we find this part, we find this is 1 minus a, we say less than 0.5 is simple. So less than 0.5 is the area for this part. So here's half. So we know this equal, this area is just 1/4. Okay. Okay. So for this problem 120, let's see. We want to calculate the probability that the claim is processed in 3 hours or more. 3 hours or more. So this is just we want to find the probability that the time is larger than or at least 3 hours. Okay. Okay. So let's say choose claim on this policy is processed in 3 hours. So let's say that here we have 2 variables. So this so processed. So what is the? So here we have x and y. So what is the x and y? So x is loss, right? And process is y. Okay, process is y. So we want to find this, like this process y is larger than 3, like this, right? Okay. We want to find this, right? Calculate the probability that landing choose claim. Yeah, the process time is at least 3. So for this probably we need to know the joint density function. Okay, so here's the same story. We have marginal density function for x, and so we also have we want to find the conditional. So here, conditional density function for y. So here, let's see, use graph. So x between 0 to 2. Okay, 0 to 2. So this is for given size x. For given size x, x equal x. This y is uniform distribution from x to 2x. So this is y equal x, and this is y equal 2x. Excuse me. Okay, so we know the region integration part is this triangle, right? This triangle. So y equal x, y equal 2x. So here x equal 2. Okay. So we want to find y larger than 3. So here is y equal to, here, so y larger than 3. So y equals 3. Y larger than 3 is this part. Okay, is this part. Okay, so we just find, okay, this for this integration. So x, the range for x is from this point, from this x, so this x to this x, then y from here to here. So here we need to find a joint density function. Let's say f x y. So same way, like f x y equal marginal density function. So multiply conditional density function. So conditional density function is uniform distribution from x to 2x. So there's a constant, and from x to 2x. So this constant is 1 over x, right? Okay. So we say this equals 3 over ax. This is joint density function. So again, for joint density function, just like probability for A and B. So A and B equal PA time the condition of when A is fixed, when A is, so there's a conditional probability, right? So PA is marginal density function. Yeah. Okay, so now the problem become easy, right? So there's a probability y larger than 3, so equal. So we just check this part, this region. So x from, so we can find this x. So when y equals 3x equal 3 over 2. 3 over 2, and to here the 2, there's a dx. And this y so y from 3 to 2x, right? dy. Okay, so join the density function 3 over 8x. Okay. So now, to find the result by now is easy, right? So let's just say 2 or 3 over 2 is 1.5, right? dx. So here 3 over 8x, then dy so become 2x minus 3, right? So dx. So now you can easily find this integration, right? Okay, so we can stop here, and we will solve. And thank you for watching. So see you next video. Okay.